Hey guys, this is Mrs. Weisenborn, and today we're going to finish 12.4. But before we do that, I'm going to review what we did last time, the first part of 12.4. So make sure while you're taking notes that you're pausing the video and that you're trying the problems before I work them out. So this is a review problem. This is an inside angle problem. And when you have an inside angle, you're going to add and take half. So I'm going to do 30 plus 50 and divide it by 2. So 30 plus 50 is 80 and divided by 2 is 40. So that's what this angle would be right here. That's your most basic case. Keep in mind that if my x was here or here, I would still set it up the same way, but that would result in having an x in one of these spaces. Also, make sure that the angle that you're adding are the ones that are across from x. Okay? Now if you have an outside angle, which I'm talking about this angle out here, it's outside of the circle, you're going to subtract and take half. So I do 70 minus 20 divided by 2. So that would be 50, half of that is 25. And that's a quick review of what we did last time. I'm going to start 12.4, the rest of that section, and then you'll do a checkpoint on iTest after this. So here's the new stuff. Here's a new theorem. This picture looks extremely similar to what I was just with the angles, except for now I'm not dealing with angles, I'm dealing with lengths of chords, okay? So the formula that you need for this is part times part equals part times part. I like to say pay equals pay, okay? So I'm going to take part times part and set it equal to part times part, 4x, okay? Doesn't matter which parts you do as long as they're on the same segment. So part times part equals part times part. Pay equals pay. Okay, so now I'm just going to solve. 3 times 2 is 6. Equals 4x, and I would divide both sides by 4. In this case, it's a fraction. You can just do 6 divided by 4 and hit math, enter, to get it to reduce if you're not good at reducing fractions. Okay, but normally you'll have whole numbers. But that's how you do it. I'd like you to go ahead and pause the video and just try this one, and when you're ready, play the video. Okay, so I'm going to go ahead and work this one out. Hopefully you tried it first. The setup is going to be part times part equals part times part. So I'm going to take 20 times 6 and set that equal to 8 times x. 20 times 6 is 120. So I'm going to take 120 and divide by 8, and I get 15. Okay, and you're certainly welcome to draw your own circle and measure out the segments and see if this actually works. I think it's pretty cool that it actually does, so but you can find out for yourself. Alright, so that's one theorem, one left to go, almost done with notes. The next theorem is, it's kind of our outside angle problem, but instead we're not looking for an outside angle, we're dealing with lengths of secants and tangents. So these are secant segments because they touch the circle twice. Your new formula is outside times whole, outside times whole. So I like to say, ow! Okay? So I'm going to do the outside piece, x, because it's outside of the circle. The length of the whole segment is 6. That was given to me. The outside piece on this one is 3. And the outside piece, or the whole piece, I'm going to actually have to add that together. So 3 plus 4 is 7. So now I'm going to go ahead and clean this up. So I did outside times whole, outside times whole.